says then the test 3 is going to be on the 12th?
Yes. Monday.
Okay, Monday. That gives us today, the 14th and the 19th, to finish 4.9, 5.1 through 5.5. So 6 more sections in 3 meetings. Okay, we'll give it a shot. Now, if we need to push this to the 3rd, that's fine, but I really don't want to have just 1 review for the final. I would like to have 2 reviews for the final, if that's, so we'll discuss it together. Okay, so we wanted to start with an example of a function. So at the end of chapter 4, if you have your books, let's take a look. Please choose 15, 16, 17. So I would like us to, page 352. I would like us to look at a sketch of the graph of a function that satisfies the given conditions. Then we're going to graph a function if you would like to graph another function. If not, we don't have to. Then 15, 16, 17. So we choose one from there. Then I recommend maybe we want to graph another function, maybe not. And then we look at an optimization situation. Okay, so we want to look at 17. And yes, I'm recording. 1 minute and 35 already. F is odd. What does odd mean? Symmetric with respect to? Origin. Very good. Origin. Perfect. F prime of x is less than 0 when x is between 0 and 2. F prime is greater than 0 for x greater than 2. F double prime is greater than 0 when x is between 0 and 3. F double prime is less than 0 for x greater than 3. And we are told that limit of f of x as x approaches infinity equals -2. I highly recommend what?
Chart.
Yes, because it's easier if you summarize all the information in one spot. It's easier to come up with an example, and there is more than one correct answer, as we know, in these situations. F prime, f of x, f double prime, and let's see what we have. So it says f prime is less than 0 between 0 and 2. Obviously, I have to have 0 and I have to have 2. And f prime is negative here. I don't know if this is a critical number or is our critical number coming from f prime being 0 or being undefined. I don't know that. But I know that this is taken care of already. Then the next one says f prime is greater than 0 for x greater than 2. So this is taken care of. Then the next one, it says the second derivative is positive between 0 and 3. So obviously I need 3. Between 0, oops, I shouldn't write that, I'm sorry. I said 0 and I put 0 in there. So between 0 and 3, the second derivative is positive. Done. And the second derivative is negative for greater than 3. Done. There's nothing else. Oh, yeah, there is. So limit of f of x as x approaches infinity is -2. So I have to write infinity here and -2 here. The limit of the function when x approaches infinity is -2. This clearly says y equals -2 must be a horizontal asymptote at infinity for sure. That's what this means. Okay, and now this. So whatever I graph in the first quadrant, I have to have a copy in which quadrant?
3.
Very good. Across the origin. So I'm going to say copy across the origin. Whatever. I don't know. Whatever I come up with, I have to copy it across the origin. If this is in the second quadrant, then I'll copy in the fourth. If this is in the first, then I copy in the third. Obviously, between 0 and infinity will be in the first quadrant, so you can write in the third quadrant. Okay, so now everything is taken care of. Now the rest, I do what I want, as long as all these conditions are fulfilled. Okay. This says that there is a horizontal asymptote at -2. Y equals -2. It was -2, correct? Did I copy it correctly?
Yep.
Always keep an eye on what I copy, please. So at x approaches infinity, y equals -2. I have to have 0, 1, 2, and 3. So the function must decrease between the x value of 0 and 2. So between 0 and 2, I don't know how, but I know that eventually it has to do this. But I know also it increases from 2 to 3. So, and then I should put the symbols here so I don't forget. So it's opening upward between 0 and 2, and actually between 0 and 3, it will be opening upward, and it's decreasing, and it appears that this is a point of min, so local min. So from 0, it doesn't say that it's undefined or defined. I'm going to make it defined. I preferred it defined, so I'm going to say it's 0. I don't know. It's 0. It reaches a minimum when x is 2. Let's see if it works. Don't copy it just yet.
I think it has to go below the asymptote.
So that's what I was saying. So don't.
It has to be concave down after 3.
So it has to be concave.
And
So
it has to be a positive slope
so
after 2.
so it has to have a minimum, and then it's increasing, right? So it continues to increase. It's all increasing. So yes, in that case, I can start somewhere else. That's why I said, give me a second to figure it out. So don't copy it yet. So in that case, 0, 0 is not the best option. So if I do this then, decreasing, it comes to a minimum, and at 3, it has an inflection point. So I'm going to say it starts 1, 2, 3, 1, 2, 3. It starts here. So it comes down to a minimum. It increases to 3, where it has an inflection point, and then opens down towards -2. That's one option. Now, since this happens in the fourth quadrant, so till we saw it, this is going to be in the fourth quadrant, so this is, then I have to copy it in the second. Now, I have to copy, definitely, the same asymptote, but positive asymptote. So on the positive side. So this will be y equals 2, because the function we are told is odd. So it has to have a complete copy here. So I started at -3, so here I have to start at +3. So this is 1, 2, 3. At -3, we'll have an inflection point. And at 2, it will have -2 will have a maximum. Maybe it's a little bit higher. I have to make it symmetric. So this is my example. Do you have to do the same thing? No. You can still start at 0. You can start at 0, you can bring it down and then an inflection point, but make sure that it's opening downward between 3 and negative infinity and positive infinity, approaching -2. Now also, what else could I do here? You can go further down. You can go, you can start here, but then if you start here, then the other side has to be here. Now I can no longer have 2 close points. So if this has to be symmetric, then I will have to have open points in both cases. I cannot have, or you can say, oh, fine, but you can still put the point here. Yeah, I could. But those have to be identical, and they cannot be full points, because then this is not a function. So that's why you need a little bit of thinking and a little bit of trial and error maybe sometimes. So then these must be open points.
Why didn't you start at 0, 0?
Because I had a problem. I could have started 0, 0, and I could have done this. Because a function can cross a horizontal asymptote, can cross a horizontal or slant. It can never cross a vertical. But because I'm asked to make it odd, these two cannot be both closed. And it cannot be one closed, because then it's not symmetric anymore. It doesn't mean that you have to make the function undefined at 0. You can still say it's defined at 0, 0. So that was an example of a function. Okay. Now, do we still need another graph of a function, or we move on to choosing an optimization directly? Optimization?
Yes.
Yes. Okay, very good. So let's what about problem 52 on page 353? Read it and let me know yes or no. Oh, and also Stephen says Newton's method. Okay.
So page 353.
353. Problem 52. We had something similar in related rates, but this is not that case.
Yeah, let's do this one.
Yes?
Yes.
Okay, perfect. So let's look at 53 on 353. Find a point on the hyperbola xy equals 8 that is closest to the point 3, 0. Oh, of course. Why am I not surprised? It is 52. Thank you. Oh, you meant 53? Okay, I'm sorry. So I think Joey read 53. Okay, let's look at 53. Find the smallest possible area of an isosceles triangle that is circumscribed. That will not be the case, for sure. Not for a triangle. Thank you. I'm sorry. That was funny, wasn't it? Okay. And I'm not even. Okay. Find the volume of the largest circular. Okay. Find the smallest. I'm looking at 3 different problems.
Let's go back to this here.
I will put that in my notebook. I have a notebook. One time I said something that I didn't even realize. So anyway, that's for some other time, not for now. Okay, this is good. This is a good one. I'm gonna tell it to all my friends.
I'm glad you're recording.
Yes, it's also recorded. I can't even deny it. Okay, I'll have to send them the link. So small. Okay, which one? Anyway, 53. Find the smallest possible area of an isosceles triangle that is circumscribed about a circle of radius r. So how do we do that? So the triangle is an isosceles, meaning two sides are equal and two angles are equal, or congruent, we say. And and the radius, the circle is inside or outside. It says about. So this is how I understand it. So let's say this is y and this is y. These two angles are equal because it's an isosceles, not equilateral, but isosceles. And I think that the circle is here.
That make it an equilateral triangle?
It does. We are told it's an isosceles triangle. So only these two sides are equal. Only this and this. So we want to find the smallest possible area of this triangle. So area of the triangle, find the smallest. Right? And we're told that the radius is r. Maybe the way I drew it, it gives you the impression that this is an isosceles, is an equilateral. So let me do this. So it doesn't look like it is. Is this better? So it doesn't look like it's equilateral. So this is y, let's say this is x. Here is r and r and r. Perpendicular. Okay? So we want to determine the smallest area that will include this circle of radius r. Okay, so first of all, the area, so we know that these two angles are equal. We'll see in a moment what we are going to do. So the area of this triangle is definitely x multiplied by the height divided by 2. Now, the difficulty here is that we have to think in terms of, I shouldn't say difficulty, we have to look at this triangle and this triangle. As you see, they have a common angle, and they are 90 degrees. They have a right triangle, right? They are right triangles. These two are the same, and this is the same. So these two triangles are similar. So this triangle and this triangle. So this triangle and this triangle. They are both right triangles. This side is R. This piece is the height. And this piece is the height minus R. This piece. So this one is the small triangle. So then this is r, and this piece is the height minus r. Now in the big triangle, I have this whole thing, which is y, and this is what I don't know. We'll see in a moment if we need it. I hope I don't. So far so good? Okay. What am I trying to do? I am trying to find the area of the triangle with nothing else but r in it. And maybe y or x. R is given. R is a number. So I cannot, once I determine this, I have to have it as a function of x or maybe y, I don't know yet, but just one variable. And I have to get rid of the height, and the height should be dependent on x or depending on y or something. Because right now I don't even know what I have. So let's write, and we know now that, let me put some letters here, A, B, C, D, E. I will say that triangle ABC is similar, and I have to put the letters in the same order of the congruency of angles. A, angle A is still with A. B is with E, and C is with D. So this has to be very clear. A and A are the same, B and E are the same, and C and D are the same. This has to be the correct order. Have to put them in the correct order. Okay, then. So if they are similar, why are they similar? Because they have all congruent angles, correct? So now let's write proportions. Careful, careful, careful. The opposite in the small triangle is r. The opposite of A in the small triangle is r. The opposite of A in the big triangle is x over 2. So for sure, in an isosceles triangle, the height is also the median. That's always the case in an isosceles triangle as well as equilateral. But in an isosceles triangle, the height will always divide the opposite leg in 2 equal parts. So that's also the median of the triangle. So I know that this piece and this piece must equal each other. So one more time. The opposite of A in the small triangle is r. The opposite of A in the big triangle, bless you, is x over 2. I move on now to the next angle. Let's say B. Angle B has this. I have no idea. I'm going to write AC. And angle E has the opposite, which is the height. Then, what else I have? Now the right triangle. The right, that's C. C, the opposite of C in the big triangle is height minus R. And the opposite of D in the big triangle is Y. SE. So all I want to express the height in terms of x. That's my hope. I'm not going to use this because I know nothing about AC. I'm not going to bother with AC. So I'm going to use this proportion, and I'm going to cross multiply and see what happens. So ry equals x over 2 multiplied by the height and minus xr over 2. I start to like it because x times height over 2 is the area. So I'm going to move this here and see what happens. I still don't know. I can't say for now for sure that where I'm going. So I know that the area is ry plus xr divided by 2. X I like. R I like. It's a number. R I like. What I don't like is the y. But I know how to get rid of it. So from this triangle, this is x over 2. So let's see how I can get rid of y. I don't really want to involve the height again. Let me see. So y squared equals the height squared plus x squared over 4. So I have that y equals the square root of the height squared plus x squared over 4. So now I have to think how I determine this height somehow without, so the height, because I have a function now, I'm getting close, the square root, the height of the triangle squared plus x squared over 4 and plus xr divided by 2. And then I would have to differentiate, but I need to get rid of the height. So let's think of a way of getting rid of the height. I have, from the small triangle, I don't want to mess with that, right? So this will be the height minus r, this will be r. I don't really have this piece. So what else do we know about the height? So y squared. Okay, so now
Can we circumcise it?
oh no, it's a triangle. Not anymore. Okay. Okay, so here it is. This piece is x over 2. This is the radius. This is the radius. So this and this is a common piece. They have two equal legs because they are both right triangles. So if this is the same and this is the same and this is the same, these two pieces must be the same, right? So this triangle, this triangle, and this one, this is the radius. They are both right triangles, and then they have a common side, right? So side angle. So these two triangles are congruent or equal. So therefore, this piece is x over 2. If that piece is x over 2, this piece is y minus x minus. No, this piece will be, just this piece, will be y minus x over 2. Okay. Yes, of course. Let me present it better. So from the central of the circle, we have this, where we know that this is a right triangle and this is a right triangle. This is r and this is r, and this is the common side. So these two are the same, this is the same, and these two are equal angles, 90 degree. So then these two pieces must be the same. So this piece and this piece must be, these two triangles must be, we say, congruent. If that's the case, then I can determine this piece as being from the entire y I subtract x over 2 because I know that this piece is x over 2. Then this piece must be x over 2. So then this becomes y minus x over 2. And then I will be able to determine this piece that will give us the height. So the height will be r plus this piece, because now I can determine it. Because I have this and I have this. So I will be using, that's the only difficulty here, determining the height. So if I determine this piece and I add r to it, then I replace the height in terms of x. And then I can say it's a function of x. Are you with me? Okay, so this triangle then has y minus x over 2. And this piece is the height, yes, height minus r, and this is r. So what do I have? Height minus r, everything squared plus, no, equals y minus x over 2, everything squared plus r squared. And now I have to take the height from here and replace it in here. Yes, it's a lot of work because it's all letters. That's the problem in a way. We are given, actually we're only given r. So we also determined, so this is AC. So I could come back here actually. So because I determined AC. I determined AC as y minus x over 2. Okay, let's do that. So we had the first relationship, which was ry equals x over 2 times height, which is the area, minus xr over 2. And this one now, I have AC, which is y minus x over 2 over the height equals the height minus r divided by y. So these are basically the two equations that I can look at. Or I can also look at one or the other. I can also look at r over x over 2 equals y minus x over 2 divided by the height. I cannot do both because otherwise I'll go in circles. So either these two or these two. So RH equals xy over 2 minus x squared over 4. And this one, ry equals xh over 2 minus xr over 2. I have two variables actually that I have to get rid of h and I have to get rid of y. So if I solve the first one for h and I replace it in the second one, I'm just looking to see if I can get rid of anything. So if I replace xy over 2r minus x squared over 4r, and this is ry equals, we're not going to have something, so xh. So xy over 2r minus, so I'm multiplying x over 2 by this and minus x over 2 by that, x cubed over 8r minus xr divided by 2. So I got y. I have to move this. So ry minus x squared y over 4r equals negative x cubed over 8r minus xr over 2. And from here I get y. Once I get y, I will plug it back in. When we get y, we plug it back in and we're done. But it looks very cumbersome. Yes, so we have y, r minus x squared over 4r equals negative x cubed over 8r minus xr over 2. So I got the y, negative x cubed over 8r minus xr over 2. I will think about it and see if I can get an easier way. And then once we have y, I'll replace it in h. So then h will be negative x squared over 4r plus x over 2r multiplied by all that. Negative x cubed over 8r minus xr over 2, r minus x squared over 4r. So there may be an easier or shortcut, maybe. So now I have the height. It looks awful if I have to square this, but I'm going to try to simplify it. So I have the height. It's all in terms of x and r. That's all I was worried about and wanted to have. And everything else will be only in terms of x and r. There must be a shortcut to all this. So I'm going to work on this tonight when I get home, and I'll see if I can come up with a cleaner. Yes, Paul?
Yes, can we pick a different optimization?
Yeah, of course. Yeah, but I just didn't want to leave it off like that. Yes, we can pick something else. But remember, this is not enough. This is not done, right? We have to put in the function and then differentiate and set it equal to 0. There must be something easier, probably a shortcut somehow, and I'll think about it. Okay. I don't see anything. Let's look at next page, 354. Or we go back directly to optimization pages. Yeah, okay, that's fine. Let's go back. So that was section 4.7, and problems start basically on page 332. We looked at the poster problem, we looked at volume, we looked at area. So all these kind of problems are for something similar that we just looked at. 23, find the dimensions of the rectangle of largest area that can be inscribed in a circle of radius r. So that's another similar problem. Find the area of the largest rectangle that can be inscribed in an ellipse. Same type of problem. 25. Find the dimensions of the rectangle of largest area that can be inscribed in an equilateral triangle of sides such and such. Find the area of the largest rectangle that can be inscribed in a right triangle with legs such and such. A right circular cylinder is inscribed in a sphere of radius r. Oh, look at this. This is an interesting one. 35. It's in red. A piece of wire 10 meters long is cut into 2 pieces. One piece is bent into a square and the other is bent into an equilateral triangle. How should the wire be cut so that the total area enclosed is A, a maximum, B, a minimum? So that's, I think, an option.
Okay.
Yes?
Yeah.
Okay. So let's look at 35 then.
Wait. What about 40?
40. 333. A cone-shaped paper drink cup is to be made to hold 27 centimeters cubed of water. Okay, so that's the volume of a cone. Find the height and radius of the cup that will use the smallest amount of paper. So we need to determine the surface area of a cone. I'm sorry.
No, makes sense.
So we do 35?
Yeah, but you
Okay. So 35 on page 333. And we have a piece of a wire, 10 meters long. And it's cut somewhere. We don't know where. Let's say here. 2 pieces. And one piece is bent into a square. And the other piece is bent into a equilateral triangle. All sides are equal. Perfect. So I'm going to say that this is x and x and x and x, and this is y and y and y. And how should the wire be cut so that the total area enclosed? So first of all, we have to come up with the total area. So let's say, what is this length? If I bend this piece into a square.
x minus.
Okay, 4x. And what is this length? Very good. So for now, we do have the first equation, which is 4x plus 3y equals 10. Now I need to find the total area. It's the total area of the triangle plus the total area or the area of the square. So now we have to remember how to determine the area of a triangle given 3 sides. Or we need to remember or find the height. The height in a right triangle is again the median and the height. You will divvy up the base in 2 equal parts. And we know that this angle is 60 degrees. We know that any equilateral triangle would have the same length, same dimensions, and same angles. So this is 60 degrees. So I can determine this height applying sine. Sine 60 degrees is the opposite over the hypotenuse. So it's the height divided by y. This being the height. So therefore, I can write the area of the triangle as y times the height divided by 2. And I'll find the height in a minute. What is the height? Just cross multiply. Y sine 60. Plus the area of the square, which is x squared. So this will be y squared sine 60 divided by 2 plus x squared. Is this clear? Is that a yes? No? Stephen, go ahead. So in a equilateral triangle, in order to find the area, it's base times height divided by 2. So I have the base. I don't have x and y, but the base is y. But I have to determine the height. All measures of the angles must be 60 degrees. 60 degrees, 60 degrees, 60 degrees. An equilateral triangle has all sides the same, all angles the same. So 180 divided by 3, this must be 60, this is 60, this is 60. In order to determine the height, I will apply sine. Sine 60 is the opposite leg over the hypotenuse. Sine 60 is the height divided by y. The height divided by y. You cross multiply. The height is y times sine 60. And I put it in here. Y times y is y squared sine 60. So this is the area. However, it's not ready for anything because it has 2 variables. But no problem, because I do have a relationship between those 2 variables. So then from here, I will solve the equation for y. So let's say y equals, so that 3y equals 10 minus 4x. So y equals 10 minus 4x divided by 3. So I'm going to put it in. So the area now is a function of x only. I'll square 10 minus 4x over 3, everything squared. Multiplied by, how much is sine 60? 60 is not the small angle, so it's not 1/2. the square root of 3 over 2 multiplied by 2. Sine 60 is the square root of 3 over 2 and multiplied by 2 in the denominator. And this is my y squared, and this is the square root, this is sine 60 over 2. And now plus x squared. Still not a very easy function to work with, but at least it was not on 3 pages. So now I will differentiate. I will not bother with simplifying it at this point. So when I differentiate, I get 2, 10 minus 4x divided by 3 times negative 4/3. Be very careful, because this is 10 over 3, which will be 0 differentiated, but negative 4x over 3 prime will be negative 4 over 3. And multiply by this number, and plus 2x. That's why I didn't want to complicate things and try to simplify it. So now I have to, this 4 with this 4 go away. Then I have 2 divided by 9 and the square root of 3. So this and this are here, the square root of 3 and 2. So this is 10 minus 4x and plus 2x. And I should not forget the minus. So 2 over 3 times 3, 2 over 9, the square root of 3, the minus, these two go away, but there is still a negative, and plus 2x. Almost there. So a prime of x equals 0. This is a linear equation, but it has all these weird numbers. So negative 20 the square root of 3 over 9 and plus 8 the square root of 3 over 9 x plus 2x equals 0. So negative 20 the square root of 3 over 9 plus 8 over 9x plus 2x. So then 8 the square root of 3 over 9 plus 2x equals 20 the square root of 3 over 9. So whatever this is, 20 the square root of 3 over 9 over 8 the square root of 3 over 9 plus 2. But I need to simplify it, and I will. I will write that x equals, so 20 the square root of 3 over 9. The least common denominator here is 9. So 8 the square root of 3 plus 18. So then x equals 20 the square root of 3, 8 the square root of 3 plus 18. So I have to determine this. Maybe if I rationalize it, maybe that will take me somewhere. I don't know. But since they did say there is some minimum and maximum, I don't know what this is, but I know it's 0. 0, infinity. So let's plug in 0 and see what happens in A prime. So in A prime, if I plug in 0, so see the sign here, what do I get? 0. This is 0. This is 0. So it's negative. Now if I plug in, I don't know what, I have to approximate to make sure. Of course, the whole thing is 10 meters long. So if I plug in 10 meters or even 100, right? Let's see what happens. So this will be negative. It will be negative times, yes, it will be positive. No, I'm sorry, this will be negative, right? So negative 400 plus 10 is negative 300. So this will be positive, right? And this will be positive. So definitely this is a minimum. So the minimum area is when x is this. But it's also asking us for the maximum area. Minimum and the maximum. So I will have to plug in this number. I know that this will be a minimum, no discussion there, but I need to plug in this number. When x is 0, what does that mean? In other words, if we bend everything in the triangle, in other words, when x is 0, if we bend everything in a triangle, that will be the maximum area. So, and this is A. When x is 0, this is 0. What do I get? 10/3 squared multiplied by the square root of 3 over 4. So 100 over 9 multiplied by the square root of 3 over 4. How much is that? When x is 0. 100 multiplied by the square root of 3, just to have an idea what it is. Meters squared? Is that what you got?
I was just doing it off the top of my head.
Oh, okay, that's good. So multiplied by,
The square root of 3 divided by 4.
so multiplied by the square root of 3. So 4.8 square meters. When there is no square, just a triangle. And what is this? How much is that? So 20 multiplied by the square root of 3 and divided by, in parentheses, 8 the square root of 3 plus 18. So this is I got 1.09. When I plug in 1.09 in the function, let's see what we get. So here's my function, 10 minus 4 multiplied by the previous answer. I don't want to put it in. And I square that and divide by 9. And then times the square root of 3 and divide by 4. And then plus 1.09 squared. Yes, I got 2.72. I will also would like to check what happens at 10. I want to plug in 10 in the area function. Because this one may be a number, a bigger number. So this is bigger than this. This is the minimum. But if this, when I plug in 10, if this is a bigger number than 4.8, then the largest area is when we don't have a triangle at all. So we have to determine and analyze, like we did with the studying of a function. That's an example of that. Studying of a function on a closed interval between 0 and 10. So now we'll plug in 10 in this function. So 10 minus 40 is negative 30, so it's 30 because I square it. 30 divided by 3 is 10, so that's 100 multiplied by the square root of 3 divided by 4 and then plus 100. Yes, as expected, 143 square meters. So here's our conclusion. If we want a minimum area, we want x to be 1.09.
How is that number possible? Yeah.
4 times 1,409. 4. So where's my drawing? What do you, okay. So this will be 4 times 1,409. And this will be the rest. 10 minus 4.36. That will create a minimum area.
Yes, I'm more with the 10.
Yeah, the 143 meters.
Right,
So-
wouldn't it just be 10
If I
to the four
use-
times
If I
10?
use the square, so I divide 10 by 4,
2.5.
okay. So what did I do?
It should be like 6.25. Yes.
What did I do? I plugged in the area, x to be 10, right? Then I have an error in the area. I have to go back and redo this. So negative 40 plus 10 is negative 30. Negative 30 divided by 3 is 10. 10 squared times this plus 10 squared. So I have to.
10 is not x. You can't plug in 10, you have to plug in 2.5.
2.5, yes. Okay, then.
So
Yes. So then this was 2.5,
it would be 6.2.
6.2. Thank you. Thank you. Thank you. Very good. So then what do I conclude? That if we use the square, no triangle, if we bend the entire 10 meters into a square and no triangle, we have the maximum possible area.
So
If
wouldn't that make the 10 on x technically 2.5?
2.5, thank you.
Okay.
Thank you. Because it's 4x. 4x is 10. Thank you. So if we use the entire 10 meters to form a square, the maximum area will be 6.2. If we use the entire 10 meters to bend it into an equilateral triangle, we get an area of 4.8, which is nothing for us. If we use 1.09 for x, in other words, we have a triangle with a side of 1.09 and we have the rest bend into an equilateral triangle, the total area is a minimum of 2.72 square meters. Any questions? That was interesting. Any questions?